Hi everybody, welcome to today's video which will be about object-oriented programming. I'm so excited, I hope you too, so let's begin. So after this video you should understand what object-oriented programming is, or OOP in short, the terminology used by OOP languages, the anatomy, sorry I can't pronounce this word, the anatomy of object, and how to create and use objects from other programmers. So basically, object-oriented programming languages combine code and data. That enables features such as encapsulations and standard interfaces. And by the way, I'm not going to cover encapsulation in this video because otherwise it's going to take so long. But I'm gonna make a separate video about it. But anyway, the data of an object is defined through attributes, or also called instance variables. Behavior of an object is defined through methods. So here in this image, as you can see, this whole thing is our object or a class. Here are our instance variables or the data, and here are our methods or the behavior that is going to be using the data that we give, and we are going to be manipulating this data. So if you didn't understand a single thing here, don't worry, I'm going to explain it more in depth later in this presentation. And after the presentation I'm also going to give you a fresh example because I'm going to code it live. So okay, what are classes in Java? So objects in Java are implemented through classes. To put it simply, a class is blueprint or DNA of an object someone might build. So imagine you want to create an object of a person. When we are creating our class, the data that will be in the class needs to be common. For example, a person can have name, age, and we can also check if he or she is married. Maybe you can try to think what else a person can have. After we have given the common data of our object, we can give the object behavior, or as I said, methods. So for example, before that, try and think what behavior a person can have. So for example, what if our person wants to change his name for some reason? So we can create a method that I'm giving the name of it, change name, and it's gonna take a parameter name of type string and change it to whatever the user wants it to be changed to. So here I'm defining a class. Actually, I'm not defining a class, I'm gonna be talking about how to define a class. So here we have public class and the class name. Public means that we can make instances of this class, and don't worry, I'm going to explain what that is later. Then we say class, which is the keyword, which means just the object, and class name will be the name of our object. So by convention, our class name has to be the same as our file name. So for example, if the class name is called hello world, our .java file has to be hello world.java. But if our class name is called hello world and we give a file name amazing tutorial.java, it wouldn't work. So by convention also, our classes in Java are named in capitalized camel case, as you can see here. And as I said before, classes use instance variables and methods to define an object. So the data also, we can call it, or the variables, are here, and below them are the methods, because otherwise we wouldn't be able to manipulate that data if the data was below our methods. So instance variables. An object's attributes or characteristics are implemented through instance variables. Age, name, color, whatever. They are simply variables that are declared inside a class but outside of any block of code. What does that mean? Well, by block of code I mean methods, essentially. And by convention, instance variables are named in camel case, as you can see here. Methods. As I said a couple of times, behavior is implemented through methods, and methods are just like functions, but they are contained within a class. So just like functions, they have a return type, a method name, and a parameter list. Methods can access instance variables defined in the class. By convention, methods are also named in camel case. And by the way, the thing that I said, methods can access instance variables defined in the class, is so powerful and you're going to see by yourself when I'm giving you the fresh example after the presentation. So here is the example of how to create a whole class, even though it's a simple class. So I don't know why I decided to name it shoes, but anyway, whatever, it works. So we create a class shoes that takes weight, height, and color. And by takes, I mean I'm just giving these attributes, but of course it can have many more. And after initializing our variables, I'm giving a method that is not going to return anything. How do we know that it's not going to return anything? Well, we have the keyword void. Then I'm simply giving a camel case name, change color, and I'm giving a parameter, and then I say color is equal to C. And as I said, methods can access instance variables defined in the class, so we can access color here within our method. So once defined, classes can be used by other people or by yourself. A class that is using a blueprint is called an instance, and an instance is built from a class by using the new keyword. So here I'm giving an example. So we are creating an instance of the class shoes that I showed you before. And by the way, when you're creating an instance of your class, you need a main method. This one here. So we create shoes, Nike new shoes. So that, what does that mean? Well, shoes is essentially just the type of the variable. So for example, if you said string Nike, it will be the same, but just a different type. So in this case, it's shoes. And Nike is just the name of our variable. And new shoes just means the constructor of the new object. So when I say new shoes, I can access these attributes and these methods that I've created there. So in summary, object-oriented programming is all about efficiency. Instance variables plus behavior or data plus methods are equal to object. And we use class to define classes, and we use new to build instances. That's straightforward. We can also use dot to access methods and instance variables in an instance. I didn't show you that in this presentation, but I'm going to show you now in the example that I'm going to give you. So let's create a person class. So person.java. We say public class person, and as I said, your class name should be the same as your file name. So person.java and person. It's very important. So then we'll just give the attributes or instance variables. And a person can have, I guess, age. He can also have name. And I'm also going to give a boolean value that's going to be called has birthday. And I'm going to show you why. So we'll have two methods. So the first method will be a very simple one. So it will be called void change name to string n, and we will say name would be equal to n. So what I'm saying here is we're not going to return anything from this method. We're just changing the name, and this is the name of the method, and this is our new value that we're going to be assigning to our name, variable name. And then we will say void birthday, that is not going to take any parameters, and we will say age plus plus, because when you have a birthday, you know, your age goes by 1 year. And then we create a new file that's going to be the instance of our main class or main object. So we can say david.java. So we create the class, stay forward, and as I said before, you need to have your main function when you're creating an instance of a class. Don't forget that. So now we need to create the object, which is the person. So we will say person David will be equal to new person. So as I said, this is the type of the variable, this is the name of the variable, and this means we just create a new object that is just called person, and that means we can use all of these things here, all of the methods and all of the data that we've given to it. Alright, so now we'll just say David. Now let's populate our instance. So David name will be equal to David, David.age will be equal to 18, and David.has birthday, we'll say that's true. So he's lucky he has birthday tonight or today. And we'll say first we want to change his name because he wants to. So David change name, and we'll say we'll change it to Joe. Right? And before that, let me print his name first. So system out print line before change of name, and we'll say David's.name, and system out print line after change of name. Okay, so you'll see why I'm doing this after we run the program. And then the other thing I want to do is I'm going to say if David has birthday, we're going to call our function that is going to be called birthday. So remember, what this function does is just takes the age and increments it by 1. So since David has a birthday today, this thing is going to be executed. So let's print David's age before the birthday. So before birthday, here we say David.age, and then we'll say system out print line after birthday, and we'll say David age. Okay, so now let's compile both of these files. Oops, my bad. So first I need to go to the correct destination, and then I'll say javac.java. This is just my compiler. And then I'll say java.david, which means I'm running our instance class. So let me open the code first. We're saying before the change of name, it is equal to David because we're initializing it here, and we are printing it before we are calling our function, which is .changeName. So when we call our .changeName, what happens? Well, we are passing a string. And how do we know that we are passing a string? Well, we are doing it here. We're saying string n. If that was an integer, our code would throw us error. So we are changing it to whatever this value is. So then we're just printing it out. After change of name, we're saying .david.name. So after this, after we're calling this function, David's.name is always going to be equal to Joe. It's not David anymore. And then what happens is we're saying before birthday is 18 because the same thing, we're initializing it here. And then since David has a birthday, because that's true, and if true, that means that this thing is going to run basically the code in our if statement. And since he has a birthday, we're just incrementing his age by 1, and then we're just printing it. So after this, David's age will always be 19. So if we just run again David birthday, let's say he has birthday twice, and we're printing it, first need to compile it. So now what do you think his age would be if I run it? Pause the video and think. But I think that's pretty simple. His age would be 20 because we're just adding 1 to his age. So that's what I meant here. We can use dot to access methods and instance variables. So when, for example, we're saying David dot something, so for example change name, that's what I mean, that we can use methods and instance variables of an instance with dot. So yeah, that's it guys. Thank you for watching. I hope you found this video informative, And also, before I forget, I'm going to include this file and also this file in my GitHub, and I'm going to give you a link of it in the description of this video so you can play around with this code. Thank you guys for watching, and see you on the next video. Bye.